Picking up where we left off, we just discovered that formula for the slope of the tangent line that we now learned we're just going to refer to as the derivative. And it has a couple other ways to be expressed. Instantaneous rate of change, instantaneous velocity, that all means the same thing. Okay, let's get to a problem. We are going to find the derivative at A, and then we're going to find the equation of the tangent line. So we'll find the slope of the tangent line there with the derivative, and then we'll take that and go one step further and even find the equation of the tangent line. Okay, let's take a look. Our first function, f of x equals x squared plus 2x minus 1. And we're going to look at it at a equals 3. Okay. So how are we going to begin? How are we going to find the derivative for this function at 3? Well, remember our formula. So I've just gone ahead and copied it here. F prime of a equals the limit as x approaches a for f of x minus f of a over x minus a. And what I'm going to do, we're going to do this real slow. I'm going to begin just by taking that value of a and plugging it in to all the a's that I see in the formula. And there's quite a few. 1, 2, 3, 4. I'm just going to put a 3 in each of those locations. All right. Makes sense so far. So we're looking for f prime of 3. That means we take the limit as x approaches 3, f of x minus f of 3 over x minus 3. Now let's go ahead and fill in these two parts of the numerator. I know what f of x is. It's that function right there. And I can find f of 3, of course, by plugging 3 in. And I will arrive at this. So my function, I've still got f prime 3 equals the limit as x approaches 3. F of x is x squared plus 2x minus 1. And f of 3, well, if I plug 3 in, 9 plus 6 minus 1, and I subtract that, minus 14. And of course, it's divided by, still by x minus 3. Let me move everything up a little bit here. Once we have all of this plugged in, it just becomes a matter of, can we evaluate this limit? Can we figure out, can we determine what that limit equals? Well, let's start by simplifying, right? Minus 1 minus 14, x squared plus 2x minus 15 over x minus 3. Also, keep in mind, I'm just copying that limit every time. We haven't done anything with it yet, but we're still just, and same over here, we're just copying all this. We're just working with, our expression inside that limit. And once it's simplified, we got to here. Hey, can we go any further? Hey, we're dividing by x minus 3. Will this factor? I think it will. Yeah, x squared plus 2x minus 15 can factor nicely as x minus 3 over x minus 3 times x plus 5. Of course, over x minus 3. So we can cancel there, leaving just the x plus 5. And finally, we can plug the 3 in. And we found that f prime of 3 is equal to 8. That's the first part of our answer. That's the derivative at 3 for this function. Okay, this is huge. Huge. That's the slope of the tangent line for this function going through the point at 3. That is pretty cool. What I'm going to do after I finish this section, these lectures, I'm going to do a Desmos examples graphing some of these things. So I know you guys can see that there already. And we'll look at some of these graphs. If we were in class, we would definitely be putting these up on the screen sort of in the midst of each problem. It's a little bit more powerful that way. And we'll be able to see that slope. Also, just kind of think about what happened, right? Back here, once it was simplified, oh my goodness, I'm trying. My shade here is getting blown around. Think about what happened here. If we were to try to plug in 3 right there, wouldn't we get 0 over 0? If we, right, there's a hole. Okay, well, that's not new to us. You know, we've been doing that with limits all along. What does that really mean? There's a hole because we're trying to find the slope of a line at the same point. Okay, just kind of follow me there. Right, our function, right back here, x squared plus 2x minus 1. I'll just draw it, get this out of the way. It's a parabola, right? It's got this kind of, this thing. And so 3, you know, is maybe out here somewhere. And so there's going to turn out to be this tangent line. But if you try and find the slope at the same point twice, what happens? Right? Think about the formula. If you try and find, what point is that? Wasn't that the point? It's the point 314. 14 was what the value we got when we plugged the value into the function. So what are we trying to do? It's like we're attempting to find the point, the slope between the same point and itself, and we get 0 over 0. We can't do it. But it's not that there's no slope there. There is. We just can't get an answer this way. So what we do, instead of thinking of plugging 3 in, we do a limit. And we circumvent this problem of 0 over 0. We found a way to divide 0 by 0 when we do these limits with this formula. That is awesome. By saying that we approach, but we never actually make it, we can pull this sort of thing off, and we can get an answer. In this case, 8. So exciting. Okay. Let's move on. Not only did we want the value of the derivative at 3, we wanted the equation of the tangent line there. So let's figure that out. The equation of the tangent line, we're going to use, again, go way back in algebra, the point slope form of a line. And we may be going so far back you don't remember some of these things. That's natural. But maybe once you see them. So the point slope form of a line y minus y1 equals m times x minus x1. Actually, that might have come up in the review. I'm sure it did. So we know that our slope is 8 and that we are going through the point 314. Again, we know the 3, but the 14, because that is the y value of our function at x equals 3. Okay. Well, if we're going slope of 8, 3, we can just put all these pieces in. Y minus 14 equals 8 times x minus 3. Simplify that. Put it in y equals mx plus b form. Y equals 8x. And then when you simplify with the 14, you get minus 10. Okay, so what's really interesting, if you are at your computer here, I imagine you are, go into Desmos and graph the original function, x squared what was it, x squared plus 2x minus 1, and at the same time graph this tangent line equation. And you'll get something like this. So that parabola kind of dips down below the x-axis and keeps going. Then the tangent line goes right by, and it passes through the function right there at 314, but then it continues on and goes on its way. So we were able to get not only the slope, but even the full equation of that line right there at that moment. And every time I teach calculus, I've taught it for over 10 years, and every time I graph something like that, and it just blows me away that we've got the power to figure out an equation of a line like that just going through a single point on the parabola. And it's nothing all that complicated either, right? Y equals 8x minus 10 in this case. All right, again, I'll do that in a Desmos video once we wrap up this section. Let's do another one. Let me get this part out of the way. Okay. Here's a good one. F of x equals the square root of x. Ooh. We're going to do this at a equals 25. We'll need to find the derivative of our function at 25. And then we'll find the equation of the tangent line. Okay. Well, if you remember the formula, I'm just going to plug 25 in for all of the a's to start off. We'll do this nice and slow, showing all of our work. So we've got f prime 25 equals the limit as x approaches 25, f of x minus f of 25 over x minus 25. And now let's put our function in right there, and let's go ahead and compute f of 25. No big deal. So f prime 25 equals the limit as x approaches 25, and then we've got square root x, and of course plugging that in just gives us 5. So we make it to this. Okay. At this point, how are we going to take this limit? How are we going to go about that? Think, oh, well, hey, it's got a square root. It's a conjugate style. So we'll multiply by the conjugate of that numerator, multiply it to the top and the bottom. All right, square root x plus 5, square root x plus 5. We can think of the FOIL happening here. Well, that would be x. Middle terms cancel, minus 25. And of course, when we multiply denominators, we're going to keep it factored. And we arrive at this. F prime 25 equals the limit as x approaches 25, x minus 25 over x minus 25, multiplied with the square root of x plus 25. Okay, very nice. And of course, now these x minus 25s cancel out. We're left with the limit as x approaches 25, 1 over square root x plus 25. And at this point, we can plug the 25 in. 1 over root 25 plus 5, of course, f prime 25, in this case, equals 1 over 10. So there's the derivative, f prime 25, the derivative of the function at 25 equals 1/10. But we want to go a step further. We want to find the equation of the tangent line. So we know this represents the slope. the point that our tangent line passes through, well, it's at 25, and we found earlier the y value there is 5. So we've got x1, y1, m. Let's keep that on the screen. Okay. Y minus 5 equals 1/10 x minus 25. If you distribute your 1/10, add the 5 over, you'll get y equals 1/10 x plus 5 over 2. And so a lot of fun if you go back and graph square root x and at the same time graph the equation of this tangent line. I won't attempt to sketch that here on the page now, but I invite you to go check it out. That is it for this video. More to come.